Hello dear students, friends and colleagues, and thank you for stopping by on my channel. In this video tutorial, we will be looking at 2024 GCE proposed solutions for pure mathematics with statistics paper 3. I doing the presentation, my names are Tata Ernest, and I had previously made a similar presentation like this one, but for pure mathematics with statistics paper 2 as well as pure mathematics with mechanics paper 2. So if you haven't watched that video just yet, then go watch that video and return to paper 3, or watch this video and then go back to paper 2. I'll also be linking that video in the description of this video, so do check it out. I am also preparing a similar presentation like this one, but for pure mathematics with mechanics paper 3. So stay tuned to this channel because the video will be dropping shortly. This video will be quite long because we will be looking at all the 8 questions that came during this exam paper. So to this effect, I'm going to add video chapters or timestamps to each question so you can easily navigate and click on those timestamps, and it will take you to the specific question where you have difficulties in. So check the video's description, you are going to see those timestamps. Then in the course of watching this video as well, if you want to get the whole presentation as a PDF downloaded into your smartphone, your tablet or whatnot, then just check the first comment in this video's description. You'll be given instructions on what to do in order to get this presentation as a PDF. And also in the course of watching this video, if you find value in this content, then please give me a thumbs up, subscribe to my channel, and turn on the bell icon so that each time I post videos like this one, you will be amongst the first to receive it. You can also write some positive comments that is going to motivate me and give me the momentum to continue making content like this one. Thank you so much for your kind attention, and without wasting much of your time, let's start off with question 1. Now let's begin with question 1, a question on probability. The question reads, question 1, Roman 1. 2 events A and B are such that probability of A is 1/5 and probability of B is 3 divided by 20. Find A, probability of A given B, B, probability of A intersection B, C, probability of A union B. Now we have been told that these 2 events are independent. So the key word here is that they are independent. So what is the meaning of saying that 2 events are independent? Now, A and B are independent when the occurrence or non-occurrence of one does not affect the occurrence or non-occurrence of the other. And mathematically, we can write that A and B are independent if the probability of A intersection B is equal to the probability of A times the probability of B. So we can multiply out their probability. The other condition is that A and B are independent if the probability of A given B is equal to the probability of A, because A does no longer depend on B, because this essentially means that what is the probability of A given that B has already occurred? So A depends on B. But if the events are independent, then A does no longer depend on B, and probability of A given B will be equal to probability of A. I hope we are together with this one. Alright, now let's face the problem. The first question is that let's find the probability of A given B. As I've just explained over here, since A and B are independent, the key word in that question, so the probability of A given B is just equal to the probability of A, which was given in the question as 1/5. So all what you had to do here was just to use the knowledge that since A and B are independent, then the probability of A given that B had already occurred is just equal to the probability of A, and that result is equal to 1/5. So we had solved the A part of the question already. Now let's move on to the B part. The B part is let's find the probability of A intersection B. Again, A and B are independent events. What does that mean? It means that I can multiply out their probabilities, and that will give me probability of A times probability of B. And the values have been given in the question, so I am multiplying 1/5 times 3 over 20. And doing the multiplication using my calculator will give me 3 over 100. So the probability of A and B is equal to 3 divided by 100. Now, what about the C part of the question? The C part of the question is that let's find the probability of A union B, or A or B. We know that probability of A or B is equal to the probability of A plus the probability of B minus the probability of A intersection B. I just have to substitute in the value, but then I have to understand that the two events are independent, so I can multiply out this probability. So the probability of A plus B minus the probability of A times the probability of B will be equal to the probability of A union B, because the events are independent and I'm allowed to multiply out their probabilities. Now let me substitute in the values. So I'll be having 1 over 5 plus 3 over 20 minus 1 over 5 times 3 over 20 by plugging in this value. So let us take our calculators and see how we can punch and obtain the value for those probabilities. All right, this is my calculator. So on my calculator, I will just evaluate 1 divided by 5 plus 3 divided by 20 minus 1 divided by 5 times 3 divided by 20. Then hitting the equal sign will give me 8 over 25. So that means that the probability of A union B is equal to 8 over 25. I hope we are together on this one and you have understood exactly what I have done. But if you do have any questions on this, please leave it in the comment section below. I will try to answer your comment as much as I can. Now let's move on to the B part, the Roman 2 part of the question. The question reads, 60% of the population of a certain country have been vaccinated against COVID-19. During an outbreak, 1/5 of those who had taken the vaccine were infected, and 2/3 of those who had not taken the vaccine were infected. Find the probability that an individual selected at random from this country, D, is infected, E, is infected or had taken the vaccine. Now, in this question, let us try to highlight very important information there. The first information is that 60% of the population have been vaccinated against COVID-19. What does that tell us? It tells us that 40% of that population had not been vaccinated against COVID-19. Complementary event, because the two events are complementary. Now, information number 2, we were told that during an outbreak, 1/5 of those who had taken the vaccine were infected. It means that even though 60% had taken the vaccine, 1/5 of those who had taken the vaccine were infected. What does that tell us? It tells us that 4/5 of those who had taken the vaccine were not infected. So complementary event. So you see that we are using the idea here of complementary event. Now, information number 3. 2/3 of those who had not taken the vaccine were infected. So out of those 40% who had not taken the vaccine, 2/3 of those who had not taken were infected. What does that tell us? It tells us that 1/3 of those who had not taken the vaccine were not infected. Complementary event. Now that we have used our idea of complement to analyze the question, let us now put this information concisely on a tree diagram. Now, on a tree diagram, before I do that, let me let V to stand for those individuals vaccinated against COVID-19. So V prime, the complement of V, will be those individuals who were not vaccinated against COVID-19. Now let I stand for infected persons. So I prime, the complement of I, who stands for persons who are not infected. Now on the tree diagram, the first trial will be selecting an individual who is vaccinated or is not vaccinated. From the question, we were told that 60% of the population were vaccinated. So 40% were not vaccinated. That is why on this branch, I have the probability of vaccinated individuals is 60 over 100. So the probability of individuals who were not vaccinated is 40 over 100. These events are complementary. So their sum must give you 1, and 1 is a complement of the other, as I just explained. Now, out of individuals from that population who had taken the vaccine, some were infected with a probability of 1/5, as on the question. So 1/5 of those who had taken the vaccine were infected. So out of this 60%, 1/5 of those who had been vaccinated were infected. Therefore, 4/5 of those who had taken the vaccine were not infected. So the complement of 1/5 is 4/5, because 5 minus 1 gives us 4. And if we add these both, we are going to obtain 1. So let me now move on now to the other arm. The other arm are those that had not taken the vaccine. So 40% had not taken the vaccine. But from the question, we were told that out of those who had not taken the vaccine, 2/3 of that population who had not taken the vaccine were infected. So on the tree diagram, I will say 40% had not taken the vaccine, but 2/3 of those were infected. I stand for infected. So therefore, the complement of 2/3 is 1/3. 3 minus 2 is 1. So this is the probability of those who had not taken the vaccine and had not been infected, 1/3. Now, it's a good habit to always write the outcome like so, because across the branches, the events are independent. Like when you leave from one branch to the other, the events are independent. They cannot occur at the same time. So we can multiply out their probabilities. So like 60 over 100 times 1 over 5 will give us 3 over 25. And this is the probability that an individual had taken the vaccine yet is infected. So this is 12 over 25 by multiplying 60 over 100 times 4 over 5. And this means the probability that an individual had taken the vaccine and yet is infected, 12 over 25. So, and this arm tells us that what is the probability that an individual had not taken the vaccine yet is infected. So we multiply out their probabilities along the branches and we get 4 over 15. Now, one thing to know if you are on track is that if you add up all these probabilities, it must give you 1. And if it's not equals to 1, then you have probably made a mistake somewhere in your tree diagram. Go back and check it. So we are going to use our calculators and then try to add them up and see if we are going to obtain 1. Let's add them up together. So I am adding 3 over 25, 3 over 25. I add it to 12 over 25, 12 over 25. I add that to 4 over 15, 4 over 15. And finally, I add 2 divided by 15. Now, if I hit the equal sign, it gives me 1. So this tells me that I am on track. All right, so let's go back to the main presentation and continue. So the D part of the question was that let's find the probability that an individual selected at random from this country is infected. So is infected. So if an individual is infected, so the individual could be vaccinated or could not be vaccinated. So what we are basically saying is that the probability of infected will be the probability that an individual is vaccinated and infected, or an individual is not vaccinated yet the individual is infected. So we add them up like so, and these values I had already multiplied them, so it makes it easier for me to just substitute and sum them. So I'll be summing 3 over 25 to be the probability that an individual is vaccinated and is infected. I add that to 4 over 15 to be the probability that an individual is not vaccinated and is infected. So if we add up these two fractions, we are going to have 29 over 75 as our result. So this is the value of the probability that an individual is infected, 29 over 75. Now the E part of the question is, let's find the probability that an individual selected from that population or from that country is infected or had taken the vaccine. This is a key word here, or. So this is the probability of A or B, where A is infected and then B had been vaccinated. So remember again, how do we find the probability of A or B? The probability of A or B is the probability of A plus the probability of B minus the probability that the both of them has occurred together. So the probability that an individual is infected or had taken the vaccine will be the probability that an individual had taken the vaccine plus the probability that an individual is infected minus the probability that an individual had taken the vaccine and is infected. And we can read off the values from our tree diagram. So the probability that an individual had been vaccinated was given as 60%. In the question, that was 60%. So I have 60 over 100 plus the probability that an individual is infected. I just solved it over here and I had 29 over 75 minus the probability that an individual had taken the vaccine and is infected. So V intersection I, 3 over 25. And evaluating this on the calculator in the same way I did before, you are going to have 13 over 15. So the answer is 13 over 15. So we have come to the end of question 1. And if you find value in this presentation, so please give me a like on this video, subscribe to my channel, and turn on the bell icon so that each time I post videos like this one, you'll be among the first person to receive it. And if you want to have this presentation as a handout so you know what to do, check the first comment in the comment section. Question 2, descriptive statistics. And the question reads, the length to the nearest centimeters of a randomly selected 140 leaves from a certain fruit tree were measured and recorded as follows. So on the first row, we have the length of those fruit trees in centimeters. It has been given as a class, as interval. Then beneath the second row, we have the number of leaves. That is the leaves that falls within this interval. This is the frequency of the leaves that falls within this interval. And we have been asked to solve the following questions. A, state the modal class of this distribution. B, calculate the mean and variance of the length of the leaves to 3 decimal places. C, construct the cumulative frequency table and draw the cumulative frequency curve for this data. D, use your curve to estimate the interquarter range. So we have been given this table on descriptive statistics and we have been asked to solve these questions that follow. Now, the first thing to do is that let us ignore the third, the fourth, and the fifth column for now. Let us just concentrate on the first and the second column. I'll explain this as we move on. Now, these are the length in centimeters, the length of the fruit trees in centimeters, and these are the number of leaves or the frequency of those lengths that falls within this interval. So this is a class from 5 centimeters to 9 centimeters. I have 11 leaves. From 14 centimeters, from 10 centimeters to 14 centimeters, I have 13 leaves. From 15 centimeters to 19 centimeters, I have 17 leaves. You get the idea, right up to from 45 centimeters to 49 centimeters, I have just 4 leaves. I hope you get the idea. Now, the first question that came is that let us state the modal class of the distribution. Now, let us come back and look at the table. What is the modal class? The modal class is simply the class with the highest number of leaves or with the highest frequency. So if we look at the frequency, we see that the highest frequency is 25. The highest frequency is 25, so the modal class becomes from 25 to 29. So 25 to 29 is the modal class because that is the class with the highest frequency. So question, the A part of the question has been solved already. Now moving on to the B part. The B part is, let's calculate the mean and the variance of the length of the leaves to 3 decimal places. So we have to find two things, the mean and the variance. So how do we find the mean of a distribution? The mean x bar is given by the sum of x times f divided by the sum of x. What is x? X are those values and f is the frequency of those values divided by the sum of the frequency. So we sum all this frequency. Now the problem becomes that what is the x which we are going to multiply by its frequency? It's true that the length has been given in class interval from 5 to 9, but we need one value which will represent that class interval, which will be called x, and that value is what we call the class mark or the meet value. And how do we obtain the meet value? The meet value is obtained by finding the average of the class limits. So I will take 5 and add it to 9 and divide by 2 in order to obtain that class mark, or in order to obtain the meet value, which I'll call x. So if you add 5 plus 9, it gives you 14, divided by 2 gives you 7. If you add 10 plus 14, it gives you 24, divided by 2 gives 12. If you add 15 plus 19, it gives you 34, divided by 2, 17. If you add 20 plus 24, the result is 44, divided by 2, 22, right down until when you add this and divide by 2, you get 47. So this is what we call the class mark or the meet value, which represent each of these class intervals that are here. And this is a value we are going to use in order to find the mean. So how do we find the mean? We have to multiply each of the class mark by its frequency, add them all, and then divide by the sum of the frequency. In the question, we were told that there were altogether 140 leaves. So this should tie with the frequency. So if you come to your table and you add up all these values of the number of leaves, it should give you 140. You have to add, and if it is different, then there is a problem, but you have to use the result from what you have added and not what is given in the question. But it should always tie if everything is correct. Now let us now find x times f. So when you multiply, it means 11 times 7 plus 13 times 12 plus 17 times 17 all the way to 4 times 49. You are going to have 3,625. Maybe let us verify that by multiplying. So let me take my calculator and then do the multiplication and see what I'm going to get. All right, this is my calculator here. So let me then multiply. What am I multiplying? I'm multiplying 11 times 7. 11 times 7. I add that to 13 times 12. 13 times 12. I add that to 17 times 17. 17 times 17. I add that to 20 times 22. 20 times 22. I add that to 25 times 27. I add that to 25 times 27. And I add that to 22 times 32. 22 times 32. I add it to 16 times 37 plus 16 times 37. Then I add 12 times 42. 12 times 42. And finally, I add 4 times 47. 4 times 47. Now let me hit the equal sign and hope to obtain this value equal to it gives me 3,625. Oh, that's exactly what I have. So that is really good. So, and if you add up these frequencies as well, you are going to obtain 140. Doing the division will give you 25.893 to 3 decimal places. So let us just do the division together and see what we are going to get. So if I divide 3,625, I divide it by 140, then you see my answer is 725 divided by 28. But let me write this one as a decimal because in statistics it's very important. So you check on your calculator to see a button that is written A, B over C or something like that. But I'll press this button here, which simply means from the scientific notation to decimal, if I hit it up, it gives me 25.893 because I have to stop here. So I will run off this 8 to 1 and add it to 2, it becomes 3. That's why I have 25.83. So that is the result of the mean. So what about the variance? How do we find the variance? The variance can be obtained using the formula the sum of the square of x times its frequency divided by the sum of the frequency minus the square of the mean, what I just obtained here. So how the problem becomes, how do we obtain the sum of x squared times f? The sum of x squared times x basically means that I come to this table, and for each value of x, I square it, multiply it by each frequency. So basically, this is what I am doing. 7 squared times 11, I add it to 12 squared times 13, I add it to 70 squared times 17, I add to 22 squared times 20, I add to 27 squared times 25, all the way to 47 squared times 4. Then if I hit equal to, it will give me 109,665. So you are going to punch that and verify. A common mistake is that some candidates or some students always reverse the order. They will instead be squaring the frequency, that is 11 squared times 7 plus 13 squared times 12. This is going to give you a wrong result. So the right approach is to square the x values and multiply it by each frequency and sum them all, then verify that you have a value 109,665 divided by 140 minus the square of the mean, 25.893, all that squared. All right, let me take my calculator and let us punch that to see if you are going to have this, what answer we are going to have. So I am looking for 109,665 divided by 140 minus 25, 25.893, all that squared, equal to, it gives me 112.874 to 3 decimal places. So let's see if that is the result that I have. So if I go, I see I have 112.874 to 3 decimal places. Now, I have to emphasize here that this is not the only formula that you can use to find the variance. There are other formulas like this formula, for example. This formula can be used to find the variance as well. So I'm going to have x minus the mean, all that squared, divided by n. N here, of course, is the total population size, which in this case is a sum of the frequency 140. So with this formula, I'll basically be saying, what is 7 minus the mean that I obtained? 7 minus the mean, all that squared. I add that to 12 minus the mean, all that squared. I add that to 17 minus the mean, all that squared. I add that to 22 minus the mean, all that squared. Right the way until I have 47 minus that mean, all that squared, and divided by 140. Punch that, I should come back to the same result. So you can also attempt using this formula and confirm that you have the same result as what we had in this presentation. All right. So let us move on to the next part of the question. So the next part of the question is, let us construct a cumulative frequency table. So we are required to construct a cumulative frequency table and then draw the cumulative frequency curve. So there are two things for us to do here. Let's start by constructing a cumulative frequency table and then draw a cumulative frequency curve. How do we construct a cumulative frequency table? That is where we go now to the fourth and the fifth column in our table. So this is what they call the upper class boundary. And the upper class boundary is obtained by just adding a 0.5 on the upper limit of that class. So we see that the upper limit here is 9. I add 0.5, I get 9.5. The upper limit here is 14. I add 0.5, I get 14.5. Right down to the upper limit. The upper limit of the last class is 49. I add 0.5, I have 49.5. Since I'm going to be drawing a cumulative frequency curve, so those values are less than or equal to 9.5. So this is a less than or equal to cumulative frequency curve which I want to draw. That is why I have added less than or equal to sign to each of the upper class boundary. Now, how do we obtain the cumulative frequency? Because to draw a cumulative frequency curve or an ogive, you have to draw a graph of the cumulative frequency on the vertical axis against the upper class boundary on the horizontal axis. So let me explain how we obtain the cumulative frequency. So for that, we will need our calculator. So let me take my calculator again, and I'll explain to you how to obtain this. Now, how do we obtain the cumulative frequency? The first cumulative frequency is simply the first value of the frequency, because we have nothing to add. It begins with 11. So I just have 11 plus 0 gives 11. So the second cumulative frequency is just taking that 11 and adding it to the next frequency, which is 13, and adding that will give us 24. So the next one, I take 24 and I add it to the next frequency, which is 17, and that is going to give us 41. The next one will be 41 plus 20, and when you add it, it gives you 61. 61 plus 25, 61 plus 25, that gives me 86. 86 plus 22, that is going to give me 108. 108 plus 16, that is going to give me 124. 124 plus 12, 124 plus 12 is going to give me 136. And finally, I add 4 to that. That is going to give me 140. So one of the things that you can do to know if your result is right is that the last cumulative frequency must always give you the sum of all the frequencies. So now that we are okay with that, let's see how we can draw our cumulative frequency curve. So this is the cumulative frequency curve that I just drew. And here you see that on the vertical axis, I have the cumulative frequency, and on the horizontal axis, I have the upper class boundary. So I'm plotting the graph of the cumulative frequency on the y-axis against the upper class boundary on the x-axis. Now I have to choose a scale. Now if I look at the upper class boundary, I see that all of them have a common difference of 5. 14.5 minus 9.5 is 5. 19.5 minus 14.5 is 5. So this becomes very easy to choose a scale because their difference is a constant. So I have just decided that on the horizontal axis, I will start from 9.5 and I'll choose 2 squares for 5 because that difference is a constant. So I have 9.5, 14.5, 19.5, 24.5. So I know that the difference here is 5. And if the difference is 5, it's very important that I know what is the value of a subdivision, because a square, of course, has 5 subdivisions. So 2 squares should have 10 subdivisions. So if the difference between 2 squares is 5, so the value of one of the square will be 5 divided by 10. That gives me 0.5. So one subdivision along the x-axis is 0.5. So 2 subdivisions will give me 1. All right, that is okay. Now on the vertical axis, I've just choose a scale of 1 square for 10 units. So that goes up to 140. I can go on and I plot my graph now. So I am plotting. The first is 9.5 against 11. So I come 9.5 against 11. Remember, the scale on the y-axis is 1 centimeter for 10 units. So the precision will be 10 divided by 5, which is 2. So this is 10. I cannot plot 11 and move it up to the next subdivision. So I'll plot it at 12. So the next value will be 14.5 against 24. So I have 14.5 against 20, 22, 24. So 2 subdivisions above 20. And the next one would be 19.5 against 41. So I'll plot it at 42. So 19.5 against 42. This 19.5, I plot it against 40, 42, 1 subdivisions. So I'll continue like so up to the last value, which is 49.5 against 140. That is what I have. Now, I have to link up the point with a smooth curve like so. That will give me an S shape. This shape is what they call the cumulative frequency curve or an ogive. So here is the ogive. And then the next part of the question is that let's use this cumulative frequency curve to find or estimate the interquartile range. Now, how do we find the interquartile range? The interquartile range is given by the upper quartile minus the lower quartile. That is the formula for interquartile range. And now I can write it as I cure R is equals to cure 3 minus cure 1, where cure 3 is the upper quartile and cure 1 is the lower quartile. Then from the graph, how can I obtain the position of the upper quartile? Upper quartile is 3/4 or or 75% of the data. So if I evaluate 3/4 of the whole data, which is 140, I get 105. 105 is not the upper quarter, but is the position of the upper quarter. So I have to come to the graph and identify 105, which is here. Then I extrapolate up to the graph and I extrapolate downward up to the upper class boundary axis and I estimate the value. Remember, the precision here was 1 subdivision is to 0.5. So 2 subdivisions is to 1. So if I'm counting, I'll have, let me zoom in a little bit so that you can see what I'm saying. Let me zoom in like so. All right. So this is 29.5. 2 boxes I have 13.5, 31.5, 32.5, 33.5, then plus 0.5 gives me 34. So I have that the upper class boundary is 34. In the same way, to obtain the position of the lower quartile, that is 1/4 of the total value, that gives me the 35th position. And coming to the graph, the 35th position is going to correspond to a value of 18. So the lower quartile here is 18. Then that means the interquartile range will be the upper quartile minus lower quartile, which is going to be 34 minus 18. That gives me 16. Now we have come to the end of this particular question, but you know what to do if you have difficulties or question in my explanation. And also, if you find value in this video, do not forget to give me a like on this video, subscribe to my channel, and turn on the bell icon so that each time I post new videos like this one, you'll be among the first person to receive it. You know what to do if you want to get this presentation as a PDF. Just check the first comment section below. Thank you for your kind attention. Let's move on to question 3. Question 3. This is a question on discrete random variable. The question reads, a random variable x takes its values in the sets 0, 1, 2, 3, 4 and has the distribution as on the table. Given that probability that x is greater or equal to 2 is equal to 3 times of the probability that x is strictly less than 2. Calculate A, the values of the probabilities A and B, B, the expected values of x, C, the standard deviation of x, D, the expected value of y, where y is equal to 5x plus 3. So in this question, we have been given this table and we have been told that x, the random variable, takes values from 0 to 4, and these are their corresponding values for their probabilities. And we have been given one key information here, that the probability that x is greater or equal to 2 is 3 times of the probability that x is strictly less than 2. So this is a very important information that if you don't understand, you will not be able to solve this question for the values of A and B. Now, the probability that x is greater or equal to 2, this is a value 2, so x is greater or equal to 2, that means I have to add A plus B is equal to 3 times of the probability that x is strictly less than 2. So x is strictly less than 2 means x takes values 0 and 1. So I have to add A plus B and multiply it by 3. So that is the idea. So let us use this to calculate the values of A and B. So this is only going to give us one equation, and for us to solve for 2 unknowns, we need another equation to solve them simultaneously. And that equation can be gotten from the fact that if x is a discrete random variable, then what does that mean? It means that the sum of all the probabilities must be equal to 1. This is the first knowledge about random variables. So if x is a random variable, then the sum of all the probabilities must be equal to 1. So with this other equation which I'm going to obtain, I can now solve the 2 simultaneously to obtain values of A and B. Alright, let us start by applying this notion. The probability that x is the sum of the probability that x is equal to 1. So if I sum a plus a plus a plus b, my result will give me 1. So that is it. A plus a plus a plus b is equals to 1. Then simplifying will be 3a plus 2b is equals to 1. Let me call this equation 1. Now let me use also the idea that the probability that x is greater or equals to 2 is 3 times of the probability that x is strictly less than 2. So I add a plus b because that is the probability that x is greater or equals to 2 is equal to, I now take the probability that x is strictly less than 2, which will be a plus a, and I multiply it by 3. So evaluating and opening the bracket on the right hand side, I get a plus 2b is equals to a plus a is 2a times 3, 6a. So let me bring like terms together in order. I can send this a the other way. It becomes 6a minus a, which is 5a. I send this positive 2b. I have negative 2b. I'm left with 0. So that is 5a minus 2b is equals to 0. Then I call this equation 2. All what I'm left to do is to solve this equation for the values of a and b. And I will use the elimination method simply because if I add equation 1 with equation 2, the terms in b will vanish. So adding them, I have 8a is equals to 1. So a is equals to 1 divided by 8. So I've had the value of a already from the question. So how do I obtain b? I have now to substitute the value of a into any of the equations to obtain the value of b. But if I take equation 1, you are free to choose any of this equation. If I take equation 1, then I will be having that 3 into the value of a, which is 1/3. I add it to 2 times of b is equals to 1. This means that 2b is equals to 1 minus 3 divided by 8. And this means that, are we together? Because 1 minus 3 divided by 8 is 5 divided by 8. And 5 divided by 8 divided by 2 gives you 5/16. So I've had the value of a and b. So I can draw my table and plug in those values. So I'm now going now to have, in the place of a, b, and b, I'm going to have these new values 1, 8, 1, 8, 1, 8, 5 on 16, and 5 on 16. I hope we are together. Now, question B, we are asked to find the expected value of x, or the expectation of x. How do we find the expectation of a random variable? Discrete random variable to be precise. Expectation of x is given by the sum of the value of x multiplied by its probability. So I'll be taking the value that random variable s can take and multiply it by its corresponding probabilities. So I'll be saying 0 times 1/8. I add it to 1 times 1/8. I add it to 2 times 1/8. I add it to 3 times 5/16. And I add it to 4 times 5/16. And I punch the equal sign as you have the result. So basically, I'll be saying 0 times 1/8. I add that to 1 times 1/8. I add that to 2 times 1/8. And if I punch this on my calculator, I'll be having 41/16. So 41/16 is the value for the expected value of x. Now, the next question is to find the standard deviation of x. How do we find the standard deviation of x? The standard deviation of x is given by the formula, the variance of x. So in order to find the standard deviation, I must first find the variance of x. And what is variance? Variance is equals to the expectation of x squared minus expectation of x all that squared. Remember, I already have the expectation of x, which is 41 divided by 16. I only need now to find expectation of x squared, plug this into this expression, obtain the variance, and find the square root to obtain the standard deviation. Now let me move on and find the value of expectation of x squared. Expectation of x squared here means that I'm now going to square each value of x and multiply it by its probability. So I can go back to what I did here, and I will just be squaring each of the values of x, and I evaluate it in the same way to obtain the expectation of x squared. So basically, this is what I'm going to have now. 0 squared times 1/8. I add that to 1 squared times 1/8, right all the way to 4 squared times 5 all over 16. So that is going to give me the expectation of x squared. And evaluating this with my calculator, I'm going to have 135 divided by 16. So I'll plug back the value into this equation, and the variance of x becomes 135 divided by 16 minus the expectation of x, which I had solved, and the value was 41 over 16 minus 41 over 16 all that squared. And evaluating this as well with my calculator will give me 479 divided by 256. So this is the variance of x, but in the question we were asked to find the standard deviation and not the variance. So how do I obtain the standard deviation? Again, I have to find the square root of the variance. So the standard deviation becomes the square root of the variance. So I'm looking for the square root of 479 divided by 256. So 256 is a perfect square, so I can have it as the square root of 479 divided by 16. So this is the answer for our standard deviation. So we have come to the end of the C part of the question. Now, what about the D part? The D part, we were asked to find the expected value of y, where y is equals to 5 times x. Remember, x is that random variable plus 3. So in order to solve that question, I need to use properties of expectation. I will say that y is equals to 5x plus 3 as in the question. So the expected value of y will be the expected value of whatever expression I have on the right hand side. And if I distribute expectation from the properties of expectation, the expectation of 5x is 5 multiplied by the expectation of x, and the expectation of a constant gives me the same constant. That is why the 3 remains unchanged. And expectation of x, as we solved it before, our value was 41 over 16. So I have to plug 41 over 16 here, evaluate the whole thing, and that will give me 253 divided by 16. So this is the value of the expectation of the random variable y. I hope you have understood, but place your question in the comment section, and also do not forget to give me a like on this video, subscribe to the channel if the video seems useful, and turn on the bell icon to receive videos like this one. And you know what to do if you want to get this presentation as a PDF. Check the first comment section below. Thank you, and we are going to move on to the next question. Question 4, a question on continuous random variable. The question reads, the probability density function f of a continuous random variable x is given by, the function is defined piecewise, so the function f of x is equals to kx when x is between 0 and 1. That function is equals to k plus 1 minus x when x is between 1 and 2, and the function is 0 elsewhere. Find a, the value of k, b, the probability that x is strictly greater than 3 divided by 2, c, the expected value of x. Given that y is equals to alpha x plus 1/3, find the value of alpha for which the expectation of y is equals to 7 divided by 6. So in this question, unlike the question which we just solved, question 3, this question is on continuous random variable. So that means we have to use another idea in order to solve this question. Now, in order to solve the question, we need to know what is a continuous random variable and how are we going to apply it to this question. All right, this is the question itself, and we have been told that x is a continuous random variable, and x is a continuous random variable if the integral of the probability density function within the limit is equals to 1. That is, from 0 to 2 should give us 1. So x is a continuous random variable will mean that the integral from 0 to 2 of the entire function f of x with respect to x must give me 1. But since the function is defined piecewise, this can be split into the integral from 0 to 1 of the first function kx with respect to x. Then I add that to the integral from 1 to 2 of the function k plus 1 minus x with respect to x, and that should give us 1. So I'm going to integrate each of these integrals separately and plug in their limit and then evaluate to solve the value of k. Now let me integrate the first part. What is the integral of kx with respect to x? Since k is a constant, I'm integrating just x with respect to x and then multiply it by k. When I integrate x with respect to x, I add 1 to the power and divide by the new power. So that will give me kx squared divided by 2. Then remember the limit is from 0 to 1. Now let me integrate the other integral and then add them up together. When I integrate k with respect to x, I have kx. When I integrate 1 with respect to x, I have x. And when I integrate negative x with respect to x, I just add 1 to the power, which is 1, and divide by the new power. 1 plus 1 gives 2. So that is why I have negative x squared divided by 2. What I'm left to do here is to plug in the limits, evaluate, and make k the subject. Now let me plug in the limit of the first arm of the result of the first integration. Now, when I plug in 1, I have 1 squared, which is 1. So I have k divided by 2 minus, when I plug in 0, it vanishes. That is why this term, I have just 1 term, which is k divided by 2. Now, let me plug in the limit for this second arm of the integration. When I plug in 2 into the entire function, I have 2 times k. Then I add that to 2 minus 2 squared is 4 divided by 2 gives 2. Then minus the lower limit. The bracket here is very essential because the subtraction is subtracting everything else that I'm going to evaluate after that. So I'll plug in 1 into the entire function, resolve it, and then subtract the result from the upper limit. So when I plug in 1, I have k plus 1 minus x squared divided by 2. So 1 squared is 1 divided by 2. I have half. So that is why I have 1 because I plug in 1. So let me evaluate everything else and then see how I'm going to solve. This 2 minus 2 vanishes. So the next step now, this 2 has vanished and I open out the bracket. Before I open out the bracket, 1 minus half is half. So I have k plus half left here and the negative distribute and give me negative k minus half. Let me just bring like terms together. These are terms in k. Half k plus 2k gives me 5 over 2k. Then minus 1k, I'm left with 3 over 2k. Then this negative half goes over and becomes positive half. That is why I have 3 over 2k is equal to 1 plus half. And if I evaluate everything here, because 1 plus half is 3 divided by 2, dividing both sides by 3 divided by 2 cancels out and k is equal to 1. So the value of k is equal to 1. So if I move on to the next question, I've had already the value of k. The next question is to find the probability that x is greater than 3 divided by 2. Since the function was defined piecewise, I have to identify the interval where I can integrate. X is greater than 3 divided by 2, and 3 divided by 2 is 1.5. But the function is defined as kx between 0 and 1, and 1.5 does not lie within this interval, but 1.5 lies between 1 and 2. I'll only integrate this function from 3 over 2 right up to 2, because from the value 3 over 2 to the upper limit, which is 2. I hope we are together here. All right, so let me go ahead. So the probability of x strictly greater than 3 divided by 2 would just be equal to the integral from 3 over 2 to 2, like I explained, of the function f of x. And that function will only exist as k plus 1 minus x. And we had solved and we had our value of k as 1. So 1 plus 1 gives me 2, so 2 minus x. So basically I'll be integrating 2 minus x with respect to x from 3 over 2 to 2. All right, so that is why I have this. So I'm integrating 2 minus x from 3 over 2 to 2. And integrating 2, I'll get 2x. Integrating negative x, I get negative x squared divided by 2. Let me plug in the limit. So I have the upper limit. I plug in 2 everywhere into the function. Minus, I plug in 3 over 2 everywhere into the function. So, and if I take my time and I evaluate the entire thing here, so 2 times 2 is 4, and then 2 squared is 4 divided by 2, and 4 minus 2 gives me 2. And if I evaluate everything within this bracket, I have just 3 minus 9 divided by 8. And evaluating finally, I'll have that the probability that x is strictly greater than 3 divided by 2 is equals to 1/8. So I have as well answered the B part of the question. So the C part of the question is, how do we find the expected value or the expectation of x? So let's see how we can find the expectation of x. And by definition, the expectation of x is equal to the integral of the entire function of x multiplied by the function f of x. And remember, the function was defined piecewise. So I'll still be integrating the two arms of this function f of x. So let us plug them back and integrate. So x has to multiply each term there. So when x multiply the first term, because here the first term here is just x times x will give me what? X squared. Now x of course needs to multiply. Remember k was 1, 2 minus x. So x needs to multiply 2 minus x to give me 2 minus x squared. That is why I will surely have 2x minus x squared. So I just have to integrate and plug in the limit. We have done a lot of integration already in this question. So I'll be having x cubed on 3 from 0 to 1. Then when I integrate this, I have 2x squared on 2 minus x cubed on 3. Let me just plug in the limit as I did in the previous questions, evaluate the whole thing, and the expectation of x will give me 1. Please, I may be fast here because we have done similar substitutions before, and I assume that you know how to substitute. But you can pause the video and punch this on your calculator to confirm that you have this value as 1. Alright, so with that, let's move on to the D part of the question. We were told that y is equals to alpha x plus 1/3, where of course x is that continuous random variable. Let's find the value of alpha, for which the expectation of y is equal to 7 divided by 6. We are also going to use the same properties for expectation like we did in the case of the discrete random variable. Alright, so what do we have? Now, we have that y is equals to alpha x plus 1/3, and the expectation of y is 7 divided by 6. So if I evaluate the expectation of y, I should also have the expectation of the right hand side. So I'll write it as the expectation of everything on the right hand side is equal to the expectation of y, which is equal to what? 7 divided by 6. And from the property of expectation, the expectation of a constant times x is a constant times that expectation, and the expectation of a constant is just equal to that constant. So I'm going to have alpha expectation of x then plus 1/3. I can send 1/3 the other way, and I have alpha times expectation of x is equal to 7 over 6 minus 1/3. And 7 over 6 minus 1/3, you can evaluate that, but expectation of x was equals to 1. So alpha times 1 will just be alpha, and 7 over 6 minus 1/3, 7 over 6 minus 1/3, let us evaluate that really quick. 7 over 6 minus 1/3. So I'm looking for 7 on 6 minus 1/3 minus 1/3. That gives me 5 all over 6. So if we evaluate that, we are going to have that our alpha is equal to 5 over 6. Expectation of x is 1, as we had solved. So alpha is 5 all over 6. I hope you have understood what I've solved here, but go to the comment section in case you have a doubt. And also, if you find value in this content, please motivate me with a like on this video, subscribe to my channel, and turn on the bell icon to receive videos like this one in the future. And also, to get this detailed solution as a PDF, check the first comment section below. Thanks for watching, and let's move on right now to question 5. Question 5, special continuous random variable, the normal distribution. Roman 1. In an experiment, the length L of a metal bar is measured many times and the observed values recorded. The recorded values are approximately normally distributed with mean 1.340 meters and standard deviation 0.021 meters. Find the probability that a recorded value A exceeds 1.37 meters. B lies between 1.31 meters and 1.37 meters. Given that 10% of the recorded values are less than L, C, find to 3 decimal places the value of L. Now, this question we are looking at is a question on normal distribution. It's very important to know the type of distribution you are dealing with. And we have been given 2 parameters, the mean to be 1.340 meters and the standard deviation to be 0.021 meters. Now, what do we need to know? The first thing we need to know is that we need to write out the information from the question. That the mean mu is 1.340 meters, not centimeters, and the standard deviation is 0.021 meters. Now, since x is a random variable, so it follows a normal distribution with mean 1.340 and variance 0.021 squared. You have to understand that a normal distribution takes in 2 parameters, where the first parameter must be the mean and the second parameter must be the variance, and not the standard deviation. That is why we had to square the standard deviation in order to obtain the variance, because the square of the standard deviation is the variance, or the square root of the variance is the standard deviation. Alright, now x here is a random variable representing the length of the meter bar. The first part of the question is that let us find the probability that the length exceeds 1.37 meters. The key word here is exceeds, and exceed means greater than something. So we are looking for the probability that the length of that meter bar x is strictly greater than 1.37 meters. In order to solve this problem, we have to know the knowledge of standardizing a normal distribution. Now, if x follows a normal distribution with mean mu and variance sigma squared, to find the corresponding z values, we use the formula z is x minus mu divided by sigma, where now z now is a standard normal variable which follows a normal distribution where the mean is 0 and the variance is 1. It can be seen from the normal distribution table. This is a normal distribution function, and the function tells us that phi of z is the probability that z is less than z. So it gives us the area to the left or the probability to the left of that z value. Very important. And we can also use the idea of symmetry to find the probability of negative values, like phi of negative z is equals to 1 minus phi of z. Are we together? Alright, I hope we are on the same lane here. Alright, so we have to standardize this particular random variable. And to standardize it, let me go once more to the formula. I will have that the standard normal variable z is equals to x minus the mean divided by the standard deviation. So coming back to the solutions, I will have that x is the x value I have here, 1.37. I've just added a 0 there just to write the number to 4 decimal places, but it will not affect the result at the end. So minus the mean, 1.340 divided by the standard deviation, 0.021. Evaluating this quantity on the right hand side of the inequality, I am going to have 1.429. So I'm looking for the probability that z is strictly greater than 1.429. But remember, this standard distribution function only gives us areas that are less than the z value. So for probability greater than z, we have to use the idea of symmetry. So we have that the probability that z is greater than 1.429 will be 1 take away the probability that z is less than 1.429. So this skill is very important to use symmetry and obtain the values for probability greater than a z value. Alright, so at this point now we have to find what is the probability that z is less than 1.429. So our z value is 1.429, and we have to go to our table and find the probability that z is less than 1.429. So this is the normal distribution function and a standard table. So I identify the value of 1.429. So how do I identify the value? This is the Z values here. We have this column as Z value, and these rows are also the Z value. So to identify 1.429, I need to identify 1.4 this way, and then I go to 9 and see where the two values intersect. This is 1.42, I mean to say 1.42, and 1.42 intersect at 0.9222. So I need now to add a last value, which is 9, and I have to go to the add column of this table and look at 9. So I follow this column to where it will intersect with this value, and I see that I have to add a value 13. But how do I add 13 to 0.9222? If you just add 13 directly, you are going to have an answer greater than 1, which is wrong because probability can never be greater than 1. So in order to add 13 to this value, we are supposed to ignore the decimal point, add 13 to the number, and then place the decimal point where it belongs. So let me take my calculator and evaluate that so that we see together. So this is my calculator, and I'm going to be evaluating the value. So I'll be taking 9222, I ignore the decimal point, 9222, I add 13 to it, and it gives me 9235. So I come back and I place my decimal at the front of the number. So that value is going to give me 0.9235, and subtracting it from 1 gives me 0.0765, and therefore the probability that x is strictly greater than or exceeds 1.37 is equal to 0.0765. I hope you are together. Alright, so the first part of the question is answered. What about the second part, where we are asked to find the probability that recorded value lies between 1.31 meters and 1.37 meters? We have to do exactly the same thing, only for the fact that we have to standardize the both sides of that Z value. So we are looking for the probability that recorded value lies between 1.31 and 1.37 meters. So we standardize both sides as I explained here by using the standard normal variable. So I'm going to have the x value 1.31 minus the mean 1.34 divided by the standard deviation, and this way I have its own x value, which is 1.37 minus the mean 1.34 divided by the standard deviation 0.021. Now let me evaluate the both sides of the z value, and I'll have negative 1.429 is less than z less than 1.429. Now how do I solve this? To solve this, I will find the probability that z is less than the top value minus the probability that z is less than the bottom value, like so. And this one becomes easy because I can read it from the table, because the table gives me the area to the left or the probability of z less than that z value. But now, since I have a negative z value here, I have to use the idea that phi of a negative z value is 1 minus phi of that positive z value. So apply it here, I'll be having phi of 1.429 minus 1 take away phi of 1.429 is now positive. Let me just multiply out the bracket and bring like terms together. So negative distribute and this term becomes positive. I add it to this like term, so I have 2 times of phi of 1.429 minus 1. And in the previous part A, we evaluated phi of 1.429 and had an answer of 0.9235. So let me substitute that and evaluate, and that is going to give me 0.8470. So I've had the value of the probability that x lie between those two values. Alright, let me now move on now to the C part of the question, which we were told that given that 10% of the recorded values are less than L, find to 3 decimal places the value of L. I can express that mathematically as the probability that X is less than L is equal to 10%, 10 over 100. And 10 over 100 is 0.1. So I also need to standardize this left-hand side. And so I'll be having the probability that Z is less than L, the X value minus the mean, divided by the standard deviation is equals to 0.1. So at this point, you could go ahead and find phi inverse and now find phi inverse of both sides. But we will not do that here. We have to manipulate this expression a little bit, because if you look at this table critically, you will see that this table only gives us values of probability greater than 0.5. So for probabilities less than 0.5, we have to play a little bit of gymnastics by factoring out -1. So if I factor out -1 from this term, I'll be having -1 into the signs of the terms on the numerator will change, so that if I multiply it back, I'll return to exactly the same thing. So this is what I have. Then I can use symmetry once more, and I have that this will be 1 minus the probability that Z is less than the positive value of this Z. At this point now, I can subtract 1 from both sides, and I have that negative the probability that Z is less than this expression is equal to -0.9. Multiplying both sides by -1, the negative cancels out, and now at this point now, the probability that Z is less than 1.34 minus L divided by 0.021 becomes phi of that entire Z value is equals to 0.9. Since phi is a function, I can find phi inverse of both sides, the inverse of that function, in order to liberate the bracket and proceed to find L. Now, taking phi inverse of both sides, I have that 1.34 minus L divided by 0.021 is equal to phi inverse of 0.9. Now, what is phi inverse of 0.9? Remember, 0.9 is a probability. So the question is that, what are the Z values? What is the Z value for which its probability is 0.9? So I'm looking for the inverse, the reverse process of what I've been doing on the table. So if I come back to the table, I'm simply looking for the Z value for which its probability is 0.9. So I have to look for 0.9 on this table in order to match out their Z values. But if I look at it keenly, there's no 0.9000. The closest value to the right will just be 0.9015. But this value is already greater than 0.9. So I take the closest value to it, but to the left. So I will identify 0.8997. When I identify this, I look at its Z value. The Z value will be 1.28. So that is 1.28, the Z value of this probability. But this is not what we were asked to look for. We were asked to look for 0.9. So I need to find the difference and see what I'm going to add to it in order to obtain that Z value. So let me take my calculator and then try to evaluate. So I'm going to find the difference between 0.9 and this value that I've used to find the Z value, which is 0.8997. So it gives me, let me change that to a decimal, 0.0003. So I ignore the zeros and it gives me a number 3. So I need now to come and I identify the 3 here and then add that value to the 1.28 that I already have. So but 3 is not here. I round it up to the closest number, which is 4, and I move up and I see that I need to add 2 to that Z value. So now my Z value becomes 1.282. I hope we are together on that one. All right. So if I come back to the Z value, I'll see that evaluating that gives me 1.282. I'm just left to apply some algebraic skills to obtain a value of L. So I multiply both sides by 0.021. Then I subtract 1.34 from both sides and multiply the result by -1. And L will give me 1.313 meters. So that is the value of L. I know there is a lot for you to digest in this question, but if need be, you can pause the video, try to solve and return back and follow up. So, but if you do have some questions, go to the comment section and type it there. I'll come and I will try to answer them to the best of my knowledge. All right, let us move on now to the B part of that question 5. In the train station, the time t in hours between the arrival of two trains is a random variable with an exponential distribution having a density function. F of t is 3 e raised to the power negative 3t, where t is strictly greater than 0. A train arrived at 9 a.m. What is the probability that the next train will arrive in less than 3 hours? So I'm literally looking for the probability that x is less than 3 because the time in this expression is in hours. So I'll just be integrating this expression from 0 to 3 because it should not exceed 3 hours. So I'm just integrating this, and 3 is a constant. I bring it out. Now to integrate this exponential function, I just differentiate the power and multiply this expression by the reciprocal. When I differentiate negative 3t, my answer is negative 3, and the reciprocal is negative 1/3. So I'll just have 3 into negative 1/3 e raised to the power negative 3t. Okay, this dt is no longer there since I've already integrated. 3 takes care of this 3 and gives me -1. So I just have now to plug in the limit. When I plug in the upper limit, I have negative e raised to the power negative 3 times 3 gives -9. Then minus negative gives me positive. When I plug in a 0, e raised to the power 0, which is 1. So our result is 1 minus e raised to the power -9. And if you insist to write it as a decimal and punch that on your calculator, it will give you 0.999. So I know there is a lot for you to digest in this particular question 5, but pause the video, go through as many times as you can, and ask questions where you have not understood. And also give me a like for the effort I make, and subscribe to my channel for more content like this one, and click on the bell icon to get notified each time I post videos like this one. And to get the PDF, check the first comment section. Thank you for your kind attention. Let's move on to question 6. Question 6, special discrete random variable, binomial distribution. The question reads, a company manufactures memory cards, and 1 out of 100 cards manufactured is known to be defective. The memory cards are packed in packs of 10. What is the probability that A, there will be at least 1 defective card in the randomly selected pack? B, exactly 2 defective cards are found in the pack. The company offers a replacement guarantee if a pack contains at least 2 defective cards. C, what percentage of the packs would the company have to replace? Alright, this is a question, and the first question that comes to our mind is that what distribution are we going to use to solve this problem? But the information from the question can guide us know what distribution we have to use. Now in the question, the first information is that 1 out of every 100 cards is defective. And this already gives us a probability. And since the question is talking about defective card, so this should be the probability of success, 1 out of 100. And again, in the question, we have been told that the memory cards are packed in packs of 10. So this 10 is the number of trials. So what distribution takes in success and number of trials? Of course, the answer is the binomial distribution. So because the binomial distribution takes in 2 parameters, where one is the success, P, and the other is the number of trials. So we are going to write it down and proceed to solve the problem. Now, we know that the probability that a single memory card is defective, let me call that P, is 1 divided by 100. Doing the math gives us 0.01. This means that the probability of failure, which is cure, is 1 minus success, and 1 minus the success will be 0.99. So I've had the probability of success P to be 0.01 and the probability of success cure to be 0.99. And now let X be the random variable for defective card. N is equal to 10, the number of trials. So X will follow a binomial distribution where it takes in two parameters, the number of trials 10 and the success P, which is 0.01. So this is how we express a binomial distribution mathematically with the two parameters. Alright, let's go now to question A and solve. The A part of the question is, what is the probability that there will be at least one defective card in a randomly selected pack? So our point of interest here is that we are looking for the probability that at least one card is defective. At least means the number of defective cards should be from 1 and above. So I can write it mathematically as I'm looking for the probability that X is greater or equal to 1. So, and I can use the idea of symmetry and I write it as 1 minus the probability that X is strictly less than 1 because it's a random variable. And now since binomial is a discrete random variable, a value which is strictly less than 0 must be 1. So I'm looking for the probability that X is equals to 0 and then I subtract it from 1 to obtain the required result. Now if I come to the distribution of a binomial distribution, I have that the PDF of a binomial distribution for a discrete random variable X is given by the probability that X is equals to X is n combination X. I have a cure raised to the power n minus X times P raised to the power X for X beginning from 0 right on to the value n, where n in this case is 10. Alright, so what is cure? Again, cure is the probability of failure and P is the probability of success. N is the number of trials, and now I'm looking for the probability that X is equals to that particular X value. And what is cure again? Cure can be obtained by saying 1 minus P. Alright, back to the solution. So we have to express this and use the PDF for a binomial and evaluate the probability that X is equals to 0. So I'll just substitute and that will give me n, which is 10 combination X 0, and now I have the value of cure 0.99 raised to the power n minus X, 10 minus X, then times P 0.01 raised to the power X 0. So you can evaluate that to see what you're going to obtain. So I'm going to be using my calculator and we'll do the evaluation together. So I'm having 1 minus, I have 10 combination 0, so I can punch 10, shift combination 0, 10 combination 0, times 0.99 raised to the power of 10 minus 0, 10 minus 0, are we together? Then times 0.01, all that raised to the power 0. Then let me hit the equal sign and I see it gives me a result of 0.09562 if I want to round it off. So let me see if that is what I obtained when I was solving. So it gives me 0.0956. So exactly what the calculator gives us. So this is how we punch it. So when we are going to meet this evaluation again, I will just allow it so that you punch and verify the results, because I've already shown you how this can be punched on the calculator. Now let's move on now to the B part of the question. And the B part says exactly 2 defective cards are found in the pack. So the random variable has a value of 2. So I'm looking for the probability that X is equal to 2. So I just have now to use again the PDF for a binomial distribution and evaluate. So X is equal to 2. That will be 10 combination 2, 0.99 raised to the power 10 minus 2, and 0.01 raised to the power 2. Now I'll give you the chance to punch this on your calculator. You can pause the video, punch and then verify if you are going to have the same result with what I have here. Then if you punch it correctly, you are going to have an answer of 0.004152. So this is the probability that exactly 2 memory cards are defective. Now let's move on now to the third question. The company offers a replacement guarantee if a pack contains at least 2 defective cards. So if a pack of those 10 cards contains 2 or more memory cards that are defective, the company will have to replace the pack. So the question now says, what percentage of packs will the company have to replace? So we are supposed now to find the probability that at least 2 cards are defective. At least 2 cards are defective. That means from 2 and above. So we can write it now as the probability that X is greater or equal to 2. At least 2 cards are defective. We can use the idea of complementary probability again for us to solve this. And so we are going to have that the probability that X is greater or equal to 2 will be 1 minus the probability that X is strictly less than 2. So how can we express the probability that X is greater or equal to 2? It can be expressed as 1 minus the probability that X is strictly less than 2. What is the probability that X is strictly less than 2? Is the probability that X is equal to 0 plus the probability that X is equal to 1. Because X is a discrete random variable. It takes only whole number values. So I have to evaluate the probability that X equals to 0, evaluate the probability that X equals to 1, add them and subtract the result from 1. I hope we are together. So I will express them individually. Let me start with the probability that X equals to 0. I just punch in the 0 everywhere else. I evaluate. I'm going to have 0.9044. What about the probability that X is equals to 1? I also punch it in the PDF for the binomial distribution. I evaluate everything and I'll have 0.09135. Then I now have to plug it into this expression and then evaluate it. So if I plug it, I'll be having 1 minus the sum of these two probabilities. Evaluating this with your calculators will give the probability of X greater or equal to 2 to be 0.00425. So this is X greater or equals to 2. That is what we were looking for. So this is the result. I hope we are together. So what I'm saying is that this is the probability that at least 2 memory cards are defective. But now the question says that the company offers a replacement guarantee if a pack contains at least 2 memory cards. What percentage of packs will the company have to replace? We already have the answer. But all what we have to do is just to express this probability as a percentage by multiplying it by 100. So the percentage of packs that the company will have to replace is approximately 0.00425 times 100. That gives us 0.425%. So the percentage of packs to be replaced will be 0.425%. So I hope you have understood, but go to the comment section in case you have doubt. And if you find value in this content, please give me a thumbs up on this video, subscribe to my channel, and turn on the bell icon to receive notifications about upcoming videos. And you know what to do to have this presentation as a PDF. Check the first comment section below. Thank you for watching, and let's move on to the next question. Question 7. Sampling and hypothesis testing. 7 Roman 1. A large population consists of equal number of digits 2 and 4. A. Find the mean mu and the variance sigma square of this population. B. Construct the probability distribution of the mean x bar of all possible samples of size 3 taken from this population. Alright, in this question, we have been given a large population, and in that population, we have been told that it has equal digits 2 and 4. And we have been asked to find the mean, mu, and the variance sigma square of that population. This question is straightforward, as the mean will just be the sum of these two data divided by 2, because I just have 2 and I have 4 in that population. So to obtain the mean will just be equal to 2 plus 4 divided by 2, which will be 6 divided by 2, so the mean is equal to 3. Now what about the variance? The variance can be obtained by using the formula, the sum of the square of the difference between the values and the mean, all that divided by 2. Again, because I have just 2 and 4 in that population, 2 values. Now, let me just substitute and evaluate. So I'll be having 2 minus 3 all that squared. I add 4 minus 3 all that squared, and 2 minus 3 negative 1 squared, 1. 4 minus 3, 1 squared, 1 divided by 2. So the variance becomes 1 plus 1, 2 divided by 2. So the variance is equals to 1. So the next question now is that, let us construct a probability distribution of the mean x bar of all possible samples of size 3 taken from that population. So how do we evaluate that? What we have to do here is that we have to write down all the possible permutations of 2 and 4, taking 3 of them at a time. And if you write them out, you are going to have 8 possible samples. The first one will be a sample 2, 2, 2. The second 2, 2, 4. The third 2, 4, 4. The fourth 4, 2, 2. The fifth 2, 4, 2. The sixth 4, 2, 4. The seventh 4, 4, 2. And the last 4, 4, 4. So these are all the possible permutations of 2 and 4, taking 3 of them at a time, because we are assuming that we are selecting with replacement. Now, how do we find the mean of the samples above? Now, let us find the individual mean. The mean of this first sample will be 2 plus 2 plus 2, that gives 6, divided by 3, that gives 2. So the mean of this first sample is 2. What about the mean of the second sample? I have to add these values and I get 2 plus 2, 4 plus 4, 8 divided by 3. So the mean is 8 over 3. And the mean of this third sample will be 10 over 3. The mean of this fourth sample will be 8 over 3. The mean of this fifth sample will be 8 over 3. The mean of this sixth sample will be 10 over 3. The mean of this seventh sample, 10 over 3. And the mean of the last sample will be 12 over 3, that gives 4. Now let me write out the mean so that I can construct a table for their means. So the mean of the sample above gives 8 over 3, 10 over 3, 2, and 4. Now the distribution looks like this. So these are the means. Let me write out the means in ascending order. The smallest of them is 8 over 3. Next I have 10 over 3. Then I move on to 2. And finally I have 4. Now what are their probabilities? Now if we look at this sample over here, we will see that there are 3 samples that have a mean of 3 over 8. That is why I have a probability of 3 divided by 8. And there are also 3 samples that have a mean of 10 over 3. That is why it gives me a probability of 3 over 8. I have just one sample, which is this first one, that has a mean of 2. That is why I have 1 out of 8 possible samples. And finally, I have just one sample as well that has a mean of 4, which is this last one. That is why its probability for the mean is 1 out of 8. Now, this is a distribution for the mean as we have here on the table. I hope you have understood, but if you do have questions, leave them down there in the comment section. Now, the B part, the Roman 2 part of the question is, a machine is said to produce sweets whose masses are normally distributed with mean 15.21 grams and standard deviation 0.5 grams. To check the setting of this machine, a sample of 50 sweets is taken from the population line of the machine, and the mean mass is found to be 15 grams. Test at 3% level significance whether the machine is set correctly. The first thing to do when you are given a question on hypothesis testing is to identify if you are going to be performing a one-tail test or a two-tail test. But here, we have just been told that let's test at 3% level significance whether the machine is set correctly. And I am not seeing keywords like increase, decrease, more than or less than or similar word. So I can only assume that this is a two-tailed test at 3% level significance. because I'm looking for a change and not an increase or a decrease. So this is a two-tailed test, very important. So now that I know that it's a two-tailed test, now I know that the mean is 15.21 grams, the standard deviation 0.5 grams, and a sample of size 50. And I'm testing at 3% level significance if the machine is set correctly when the mean mass is found to be 15 grams. All right, let us go to the question and now approach it. This is the mean. The mean is 15.21 grams. The standard deviation 0.5 grams. The sample size 50, and now the mean which I want to test is 15 grams. All right, let us now write out that let x be the random variable for the mean masses of the suite. Then x will follow a normal distribution with mean mu and variance sigma squared. Now I need to state the null and the alternative hypothesis. The null hypothesis H0 is such that the mean is equals to 15.521 grams. And so the alternative hypothesis H1 will be such that the mean is different from 15.21 grams because we are dealing with a two-tailed test. If it were a one-tailed test, we will have symbols like greater than or less than. All right, so under H0, we have the distribution for the sample mean to follow a normal distribution with mean mu and variance sigma squared divided by n. So if I plug in those values, I have this. Now let me identify the type of test. So I want to perform a two-tailed test at 3% significance level. So it's a two-tailed test. So I have to divide this 3% by 2 and I get 1.5%, which is the same as 0.015 and which corresponds to a confidence interval of 98.5%. Let me explain what I mean by this. So this is a figure of a normal distribution with 97% confidence interval. So this is a normal distribution here. And these dotted lines in red are the critical values that I want to look for. Now, if these are the critical values and it's a two-tailed test, so to the right we have an area of 1.5%. To the left, we have an area of 1.5%. Now, in the middle, we have an area of 97%. All right. So, but then I want to look for this Z value here. And on the standard table, we know that the standard table gives us values to the left of that Z value. So, I have to look for this Z value here. So, to find the Z value, I can now take this 1.5%. I add it to 97%. That will give me 98.5%. So that is why I can now write that it corresponds to a 98.5% confidence interval. So that means that the probability that Z is less than that Z value is equal to 0.985 because that is the area to the left. So I can use this now to find the Z score, that is to find this Z value at this point. Okay. All right, so that means that Z will be phi inverse of 0.985. So the question is, what is the Z score when the probability is 0.985? Let us go to our normal distribution table and identify 0.985. So I have 0.985. Where is it? 0.985. Here is it. I have exactly that value. So what are the Z score? The Z score is 2.17. So I have 2.17. So that is the Z score. So even on this figure, you see that the Z score is 2.17. So that is why you are going to have 2.17. So we move on now to the rejection criterion. So we are going to reject H0 if the calculated value of Z is strictly greater than 2.17. Remember on this figure here, this is the critical values. If the Z values falls in this section, then we are going to accept H0. But if it falls outside this section to the left and to the right, we are going to reject H0. So we reject H0 when the Z value is less than negative 2.17 or the Z value is greater than 2.17. So mathematically, it can be written as the Z value, absolute value is greater than 2.17. It carries both information. Okay, now let us calculate that z value. So the z calculated value will be x bar minus the mean divided by standard deviation divided by the square root of n. And x bar is that mean that we have to test, which was what? 15 grams. So I'll be having 15 minus 15.21 divided by 0.5 divided by the square root of 50. Evaluating this gives me negative 2.998. And notice that the absolute value of negative 2.998 is 2.998, which is greater than 2.17. And so what do? We reject H naught because the calculated value of Z is greater than 2.17. So H naught is rejected, and the conclusion is that at 3% level, there is no sufficient evidence that the machine is set correctly. Okay, I hope you have understood, although there is a lot of stuff to absorb here, but you can pause the video and try to solve and move gradually to make sure that you understand. But if you still have some difficulty, just comment below on the point where you have not understood, and you can also motivate me with some comments that is going to give me that momentum to keep making content like this one. And also do not forget to place a like on this video, subscribe to my channel, and turn on the bell icon to receive videos like this one. Thank you so much, and you know what to do to get this presentation as a PDF. Now let's move on to the last question. Question 8, the last question on correlation and regression. The question reads, the following table gives the marks scored by 8 candidates in each of 2 biology examinations. So this table, we have the candidates, and the candidates are from A, B, C, D, E, F, G up to H, and below here we have the marks scored in paper 2. That marks is called X. So these are the marks scored in paper 2 by these candidates, and these are their respective marks scored in paper 3. That mark is called Y by the following candidates. Calculate A, the covariance of the data, B, the equation of the least square regression line for the mark scored in paper 3 on the mark scored in paper 2. The mark in paper 3 to the nearest whole number of a candidate who scored 80 in paper 2. D, the Kendall's coefficient of rank correlation. Now to begin with, let us look at the data. And here we have the candidates, and down here we have the marks of each of these candidates scored in paper 2, and that marks is referred to as X. And below we have the marks of the candidates scored in paper 3, and that marks is referred to as Y. Now we have been asked to calculate A, the covariance of the data. What is covariance? Let us go to the question and see how we can calculate it. The covariance is given by the sum of the X values, the sum of the product of the X and the Y values divided by N minus X bar, Y bar. So there are a number of things to obtain in order to find the covariance. The first thing to obtain is that we have to find the sum of the product of the X and the Y values. We need to find the mean of the X values, and we also need to find the mean of the Y values. So we are going to proceed to find those values right now. Now, first of all, let us start by finding the sum of the product of the X values. So if I go back to the question, then you see that the sum of the product of the X and the Y value is obtained by multiplying 84 times 83 plus 42 times 60 plus 33 times 28, and I do that right where I will be multiplying 35 times 40. So, and if I do that correctly and I punch the equal sign, I will see that the sum of the X times the Y values is equal to 30,625. And also, in order to find the mean, I must sum the X values, and to find the mean of the Y values, I must also sum the Y values. And the sum of all the X values, that is, if I add 84 plus 42 plus 33 plus 52 right up to 35, I'm going to have the value 446. And if I also add the y values, 83 plus 60 plus 28 plus 63 plus 59 plus 92 plus 73 plus 40, I will have 498. You can add that to confirm. Pause the video and add and confirm that these values are correct. So there are some question papers that the examiner does this for you and give you to use and obtain what is here. Now that we have these values, we can go ahead and we find x bar and y bar. How can we find x bar? X bar is the sum of the x values divided by n, and n is 8 because there were 8 candidates involved in that examination, and 446 divided by 8 gives us 55.75. And what about y bar? Y bar is just the sum of the y values divided by 8, and doing the sum will give us 62.25. Now with this information, I can go up to this formula and obtain the value for the covariance. So the covariance will now be given by the sum of the product of the x and the y values, which is 30,262 divided by 8 minus the product of the means. Okay, let us punch this on the calculator and see what we are going to obtain. This is my calculator. Let us punch that and see. So I have 30,262 divided by 8, then minus the product of 55.75, I close the bracket, into 62.25, I close the bracket as well, equal to, it gives me this value. Let me change that into a fraction, which is 312.3125. So that is going to give me 312.3125. Let us confirm if we have the same result. Yes, 312.3125. Now, the next question now is that we have to find the equation of the least square regression line for the marks scored in paper 3 on the marks scored in paper 2. That is what we have to look for. And how do we express that? The regression line of y on x is given by the formula y minus y bar is equals to the covariance divided by the variance of x into x minus x bar. So this is the formula for the regression line of y on x. If it were x on y, then we'll just reverse this and we'll be having x minus x bar is equals to the covariance divided by the variance of y into y minus y bar. But now, this is what we have been asked to look for. So what I have to do is that I need to find the variance of x, because this is the information I don't have, but I have the rest of the information. So how do I find the variance of x? And the variance of x is just given by the formula, the sum of the square of the x values divided by n minus x bar all that squared. So I need to come to the table and I find the sum of the x values, the sum of the squares of the x values. That is 84 squared plus 42 squared plus 33 squared plus 52 squared plus 69 squared plus 81 squared plus 50 squared plus 35 squared. And when you do that, pause the video, evaluate, and make sure that you come out with a result 27,660. Okay, now that we have this, we can now come and apply in our formula. So we have that this is the value of the covariance that we solved before. And now to obtain now the variance of x, we just take that sum of the square of the x values, we divide it by n, and we subtract x bar all that squared. Evaluate this on your calculator and confirm that you have 349.4375. Okay, now that we have the values that we need to plug them into the regression line of y on x, we can just do that and we get y minus y bar, and y bar was what? 62.25 is equals to the covariance, which was what? 312.3125 divided by 349.4375 into x minus x bar, and here is x bar. Then I can just evaluate this. I'm going to have 0.98. I distribute it into the bracket and I send this negative 62.25 to the right hand side, and I'll be having y, that line, to be 0.98x plus 12.63. So this is the regression line of y on x. So compute it and compare that. You should have the same answer with what I have here. Okay, all right, so we can now move on now to the C part of the question. The C part of the question is, let's find the mark in paper 3 to the nearest whole number of a candidate who scored 80 in paper 2. Yes, so we are finding the mark in paper 3, so we are looking for the value of y when the value of x is 80. That is straightforward, because when you have the regression line in terms of y, you just have to plug in the value of x and you have your result. So that will just be, this is the regression line and the value of x is 80. If we plug that and evaluate, you are going to have a value of 84 to the nearest whole number, because you are going to have 83 point something, and when you round up that digit, it gives you 84. So this is the mark scored in paper 3, which is y. I hope we are together. Now, the last question, it is a question that we have to find. The last question is to find the Kendall's coefficient of rank correlation. That is the last question that we have to find. Kendall's coefficient of rank correlation. Now, how do we find the Kendall's coefficient of rank correlation? The first thing to do is that we are going to draw our table where we are going to rank these values. To rank means that you write the values in order of size, either from the least to the greatest or from the greatest to the least. Are we together? But in this particular question, I will rank from the least to the greatest. If you do the other way around, you are going to have exactly the same result. So you can go test it and compare the answer with what I'm going to have. Okay? All right. So the first thing is that I'm going to rank X, to rank the marks in paper 2, and I'm going to rank the marks in paper 3. So let us do the ranking together. So if we do the ranking, you will see that in paper 2, C has the lowest value in paper 2 and the lowest value in paper 3. So this is C, the lowest value in paper 2, 33, the lowest value in paper 3, 28. Now let us look at the next person that comes up, H, that has taken rank number 2 both in paper 2 and paper 3. So if we look at H, you see that H has 35 in paper 2, which is the second value after 33, and 40 in paper 3, which is also the second value after 28. Now, let us look at the next ranking. We have B, which is the third position in paper 2, but the fourth position in paper 3. So let us look at B. You see that B has 42 in paper 2 and 60 in paper 3. So it has instead taken the fourth position in paper 3 because 59 is the third position. So you are going to continue and rank for all the marks in paper 2 and all the marks in paper 3. And when you rank them this other way, then what we have to do now, it is to match the ranking. That is, you are going to draw a line that will match the ranking. So you see that the first position matches with the first position, the second position matches with the second position, the third position matches down here with the third position, the fourth position matches with the fourth, the fifth to the fifth, the sixth to the sixth, the seventh to the seventh, and the eighth to the eighth. Now that we have done this, the next thing we have to do is that we need to apply the formula for the Kendall's coefficient of rank correlation. Now, this is the formula here. The formula states that Rk is equals to 1 minus 4k divided by n into n minus 1. Now, what is k? K is the number of intersections. Like if you look at this, my question, let me zoom in a little bit. You are going to see that these are the intersections, the crossings on the lines that are matching the rankings. Here we have a cross, a cross, a cross, a cross, and a cross. Or you can think of that as the intersection of the lines that matches the ranking. So that is the value of k. So now that we have that, k is that, and what is n? N is simply the number of of students or the number of data that are there. So we were told that there were altogether 8 students whose marks were recorded. So n is equals to 8. Now let me just come back and apply the formula. To apply the formula will just be really easy, because to apply the formula now, I'm going to use this formula and I'm going to have that RK is 1 minus 4 into 5, because I have 5 intersections. 1, 2, 3, 4, and 5. There are 3 intersections here. Let me zoom in again. There are 3 intersections. We have 1, 2, 3, 4, and 5. Alright, so the number of intersections are 5 divided by 8 into 8 minus 1. And doing the evaluation, you have 1 minus 20 divided by 8 over 7. And that will give you 0.643 as the value of the Kendall's coefficient of rank correlation. Now we have it, and so if you have a question again, place it in the comment section, and please do not forget to give me a like on this video if you find value. Subscribe to my channel for more content like this one, and turn on the bell icon so that you get notified each time I post new videos. And check the first comment section to see how you can get this presentation as a PDF. There we have it. Thank you so much for your patience throughout this video. I really congratulate you for persevering till the end. But before you click off the video, I have a couple of things to say. If you do have any questions based on this video, then write it down there in the comment section. I will read all the comments and try to answer all of them to the best of my knowledge. And if you also have recommendations for future videos, if you have a particular worry that you think a video can resolve, then also write it down there in the comment section. If there are corrections or mistakes I made in the course of this presentation, then write it down there too. I am somebody who likes to be criticized positively in order to move and improve on what I am doing. And leave your comment that will motivate me. Such comments go a long way to cause me know that I am moving in the right direction and will continue making great content like this one. And thank you so much for watching, and I will see you soon. Goodbye.